So thanks everyone for coming. The purpose of this session is really to have a discussion started on how we can collectively try to change the funding landscape for the really important life science databases. And within ELIXIR, in the last 3 years, we've had an effort in Europe to see if we can find a way to essentially nominate data resources as research infrastructure that's treated in the same way as other big machine research infrastructures. So the purpose of this session, I think, is really to share a bit of experience in running big resources, and then we have these 2 panel debates where we hope we'll have a lot of interactive discussion and see how we together can form this. This will feed into to some work that's happening on the global level, which Rolf will present a little bit later today, where there is a working group with high-level funder buy-in. So we hope that this can actually get some traction and really help to do something about it. What I wanted to do in this first talk is just give you, for the Americans in the audience, a very quick introduction to ELIXIR, and then talk a little bit about our motivation and how we got about thinking of these core data resources. So for those who don't know it, and I see in the audience that actually most people are friends and family, so you know ELIXIR quite well, but ELIXIR is a European research infrastructure. We're funded by 22 countries in Europe, and our job is really to connect the national bioinformatics infrastructures and investments across countries in Europe. And EMBL EBI is a really key component of this, and it's the service part of EMBL EBI that really is interfacing with ELIXIR, so that essentially we are aiming to promote long-term sustainable data flows between the core archives, such as those at the EBI, and all the other databases and national investments in bioinformatics. As I said, we are 22 member states, well, some of our observers, and EMBL EBI then as an international organization. And so with this, we're covering most of the research, sort of the big research institutes in Europe. What is important to know, though, is that the countries, when they join, they form usually a coalition, which is what they call the national node. And so in total, it's 22 countries, but it's over 220 institutes involved in ELIXIR through these different national nodes. And so we're really reaching out to a lot of the European sort of research base and make sure that we can have well, essentially data infrastructure that reaches out into every nook and cranny in Europe. The backbone of ELIXIR, and this is my last slide on ELIXIR, but the backbone of ELIXIR is really our national nodes. And so these national infrastructures, they are funded typically through some sort of national roadmap funding that bring together a consortium across different institutes. The example I have, I think there is a pointer. The example here is the German node, which is called DENBI, DE. National Bioinformatics Infrastructure. And that's a consortium of 39 partners that's organized in a number of service centers across Europe. So there is one, or across Germany, there's one service center for human genomic data and translational data. There is one service center for proteomics and so on. And so in each of these centers, then a number of different institutes participate, and so they try to organize the data. So this is the infrastructure part, the data part, and the tools part. It's not the research. This is really the infrastructure. And then this DENBI in turn is interfacing through ELIXIR with similar structures in most other European countries. So, and for the bigger countries, they are of a similar size. I think the Spanish Institute brings together 12 of the biggest universities. In Italy, it's a joint research center that spans all of the Italian institutes and so on. And then some of our other nodes, the smaller ones, are of course much more specialized. I see Venkata here from Luxembourg, which is a single university with essentially a single research group. But through this mechanism, we are reaching out to most of Europe. The important or the interesting part here is that because they are funded out of the national roadmaps, they do align with the national research priorities. And so, for instance, around human data and translational data, that's something that most of our nodes are very interested in. But Norway, for instance, have a lot of investment in the marine sciences, and so are leading on a lot of the marine science activities in ELIXIR, on reference databases for marine eukaryotes, and some of the leading fish geneticists in the world sit in Bergen, and they have a lot of infrastructure around, say, salmon genetics. And unsurprisingly, a node like the Czech Republic or the Switzerland don't have a lot of marine activities, and so they are focused on other things. And so this diversity and the link to the national roadmaps, I think, is a really important strength, because it does give quite a bit of resilience into how we operate. The last point I want to make, and I think that's relevant to the discussion today, sorry, Chuck, I'm going to move your bag. The discussion today is that what we are trying to create, and what we have, I think, managed in some countries to create, is really a national framework for long-term resource management. And so it is very difficult to maintain resources long-term if there is no sort of framework where the country as such can take responsibility for running the infrastructure. It becomes one of these common actor problem. All the rats want to have a bell on the cat, but it's very unclear who will go and put the bell on the cat. And I think that the solution to that is usually to create an organization, and then you just nominate someone to bell the cat. But I think what we have managed to do in some countries is to create a framework for this cat belling, for a framework where you can say, well, it is important that Sweden or Norway have a long-term view on some of our data resources. And I think the model here that we would wish that most countries start to look at is really Switzerland, with the Swiss Institute of Bioinformatics, which really provides a long-term home for some of the key databases, and they can express that value. So I think that's where we're aiming with many of our national nodes. So that's all I want to say about ELIXIR, and so to come back on to the topic today about infrastructure, I think it's clear that we have a lot of funder mandates right now on open data, and I think the weak point in many of these funder mandates is the fact that this open data does require long-term infrastructure. And within ELIXIR, we had a working group. One of the advantages of this setup with the countries as the member states is that our board consists of representatives from the national funding organizations. And so we organized a working group with some of these funders to really try to analyze this problem. And one of the things that came out of this, I think Alf Game, who chaired it, he put it very well, say, well, if we as a funder are asked to build a telescope, it's very easy. You put up a barbed wire fence, and then you build a telescope inside that barbed wire fence, and you know that everything inside the barbed wire is the telescope, and that's what you fund, and everything outside is someone else's problem. And then when you come as a community with the biological databases, you have essentially an unbound problem. There are thousands of these databases, and some of them are really important as an infrastructure, and we know that, but it's very difficult to make a decision on what to fund in the same ways as telescopes and what to fund in as a research project, which really is another part of bioinformatics research. And so that was really the starting point for our work on these core data resources, was those recommendations from that high-level funders group to try to find a methodology where you can describe, or where we can describe bioinformatics data resources as scientific infrastructure, and begin to have a debate in the same way with national funders as many other communities have around icebreakers and telescopes and synchrotrons and so on. And so that's really what we've tried to do. And there are two talks here today that I will give. The second one should have been given by Jo McIntyre, but she can't come. And so what I'll focus on now is more the high-level reasoning around these core data resources. And then in the second talk, we'll come back to and discuss what are the selection process and criteria, and how did we go about actually selecting them. But what we wanted to capture were really how do you sort of operationalize the notion of having data resources that are fundamental to life science and really help the broad life science community and the long-term preservation of critical biological data. And the sort of, they are complete collections with some generic values, so they span a large number of communities, and of course they operate at a high level of usage, scientific quality and service. So those were really the starting points, and at this point it was just words, and then we tried to operationalize that into a process. And to cut the story short, we have gone through this now 2 times, and so in total we have nominated 18 core data resources. And I think one really important part of that is through our commitment to open access, we are, all of these are open access databases. So they are accessible by the research community, regardless if that research community sits in industry or in academia. And it's also available to the broader public in education, higher research, but also, of course, a lot of work is going into education in schools around these data resources. And I think that open access, that value of open access has been really important. And we've got some tractions. We have some really nice stories where resources that used to have a more restrictive license, in order to be nominated as core data resources, have actually had debates with the national funders and moved the license. In some cases, they've even got a bit of compensation for the monetary loss that the rather modest income they had from industry contributions have been then picked up by the national funders. So I think that actually helped to drive the open access agenda, and I think that's something we're really quite pleased about. I think what it helps to do and what it enabled us to do to have this first cohort is to work with some of these database owners, and of course Christina will give a talk, CAT and Uniprot are part of the core data resources in Europe, is that we can then start to describe the impact not of individual resources but of the whole cohort, and so we can start to have that conversation with the funders. And so this is just an example. If we summed up from the case studies, the citations, so each of these resources were asked to identify 5 key papers, and then we look in European PubMed Central for the citations, and if you do a cumulative graph, you will see that it sort of bottoms out around 16,000 citations per year. And so taken in totality as a scientific infrastructure, this is really quite impressive, and most big synchrotrons have around 5,000–6,000 citations per year. So it is really a quite large research infrastructure. If you then start to look at direct citation of data records, because we know that citation practices is, I guess the polite word is variable. If we start, and Joe McIntyre has set up a text mining pipeline where they can look for identifiers from these databases in the open access literature, we see that there are over 20,000, in addition to this, 20,000 articles with direct data citations. So this data was a few years old, and direct, almost 90,000 direct citation of accession numbers in the open access corpus. And so the total impact, instead of sort of comparing resources with each other, looking at the total cohort of resources, the total impact of this infrastructure is actually quite large. And so I think that underpinned this notion of being really important in science. But the reason why we're here is that because many of these resources, so this is a slide from Guy Cochrane, are of course global collaborations. So it's great that we've done this in Europe. What we need to do now is to bring in the global community with US, Asia and other areas of the world, and see how we can really articulate this in collaboration across the continents. Because I think these sort of global collaborations is really one of the big success stories of bioinformatics, and something that we need to preserve. And so the way we've gone about this is really to say we try to establish indicators for these core data resources, and I'll talk about this later today. That enabled us to shortlist a set of resources of fundamental importance. And what we're doing now, and that's why we're here, is to try to develop some models for international support, and Rolf will talk about that. And then hopefully in the end we will end up with some model for shared international support for these data resources. So that's really the strategy, and where we're aiming to move the work that we've done in Europe and now try to bring that up to a global level. I think that the final point I wanted to make is that actually this is, and I think this is a piece of work that we're really quite proud of in ELIXIR, is that we've started to describe how this can be a substrate for an ecosystem of innovation and industrial innovation. And so, of course, EBI and many other institutes have long-standing industry programs. We looked at patents a few years ago, and it turns out that many of these resources are widely cited in patents. So we found in that corpus, we found about 31,000 direct citation of these databases in the patent corpus. And so what that means is that if you want to identify a protein for a vaccine or indeed a washing powder, the way to do that is to go to UniProt. That will be an unambiguous identifier of that protein. I think so that's fine, and we know that. I think what is interesting about this, though, is then that the patent officers, they say, well, that's absolutely a great way of identifying your protein, so they grant a patent. And suddenly you have a government agency granting 25 years of market exclusivity on the basis of an identifier in a database that run on a 3-year research funding. And so this fact that they now are a really integral part of a modern knowledge economy, I think, have been lost on many of our science funders. And I think that's something that we would like to describe a little bit better in ELIXIR. We think that's a really important argument and something that we'd like to further. I think the other part that we've done is that, of course, we would like to encourage more small companies to use these databases as well. And so we've run what we call an SME program, where we've held workshops and events with local bioinnovation hubs or biocatalysts, where over 350 companies have been visiting. And we just released a report with a small sort of first cohort of companies to describe how they use these public open access resources within their business model. After we released this in March, we've had contacts from quite a number of other companies who are really keen, and so we hope to, in the next 1 or 2 years, to provide an update with a much bigger cohort. So that's all I wanted to say, and so I thank you for coming, and I hope we'll have a really good debate today. So thanks a lot.
We have a few minutes for questions.
It may be useful to save that for the panel debates later if we, yeah.